Let's continue. So let's have now symmetry of a function. Now there are three scenarios or three symmetries of functions. The emphasis here, there are only three, although originally there are four. However, since the topic is about function, there is no such thing as symmetric to the x-axis because it violates the vertical lines test of a function, that it must cross vertical line only once for you to say that a graph is a function. We'll start with symmetric to the y-axis. This is symmetric, so this is symmetric to the y-axis. So how do you determine class if a given graph is symmetric to the y-axis? You fold along y-axis, okay? Imagine, just imagination, okay? You fold this along y-axis, and if there is symmetry in the graph, then that is symmetric to the y-axis. Now, given this example, if I'm going to fold this along y-axis, it would be like this. So you see, there is really symmetry to the graph with respect to its y-axis. So, kapag finold mo yung graph along y-axis and may symmetry na na-produce, then that is symmetric to the y-axis. Let's have the second symmetry. Now this time, this is symmetric to the origin. Okay? How do you determine if it's symmetric to the origin? In the first case, symmetric to the y-axis, you fold it only along y-axis. This time, since the basis origin, it must meet, okay? Your symmetry point must be the origin. So, you will fold it along y-axis at the same time, fold it along x-axis. So, given this example, if I'm going to fold this along y-axis, the graph would be like this. Okay? Now, using this image, which is we already folded this in along y-axis, let's fold this along x-axis. Okay? So the graph would be like this. Okay, so that is now symmetric to the origin. So there is really symmetry to the origin. Now, the last symmetry class is neither symmetric to the y-axis nor the origin. How do you determine class if a graph is neither y-axis nor origin? It's simple. You fold it along y-axis. Kapag walang na-produce na symmetry, then wala. On the other hand, if you fold along x and y-axis, kapag walang symmetry, then that is neither. This is an example of neither symmetric to the origin nor y-axis. Wala talagang mag-produce na symmetry. However, not all the times given your graph. What if the given is a function or just equation? So this is how you identify symmetry of a function without graphing. We're going to need here, again, the f of x, the negative f of x, then f of negative x. Now this is the theorem here. Without graphing, you can identify the symmetry of function using the rules below. If f of x is a function such that f of x equals to f of negative x for any values of x in its domain, then the graph is symmetric about the y-axis. On the other hand, if f of negative x equals to negative f of x, then the graph is said to be symmetric about the origin. However, if everything is not equal, then the function is neither symmetric to the y-axis nor origin. So, in our previous discussion, if f of x is equal to f of negative x, then that is an even function. Well, in symmetry, if f of x is equal to f of negative x, it is symmetric about the y-axis. So therefore, an even function has a symmetry to the y-axis. On the other hand, if f of negative x is equal to negative f of x, then the function is odd. Here in this theorem, it is symmetric about the origin. Therefore, if a function is odd, it is also symmetric about the origin. Again, to summarize this, if a function is an odd, then it is symmetric about the origin. While if f of x is equal to, while if a function is even, then it is also symmetric about the y-axis. Let's have example. Discuss the symmetry of the following function. So, let's start first with letter A, which is f of x equals 5x cubed minus x. So let's identify first the f of negative x. So solving this, our f of negative x is negative 5x cubed plus x. So since our f of negative x is not equal to f of x, we'll find the negative f of x. So solving this, our negative f of x is negative 5x cubed plus x. Now notice here that we have now an equivalent polynomials, which is our negative f of x, then f of x. So we can say, without graphing, this graph, the graph of f of x would be symmetric to the origin. Next, let's have the second problem. G of x is equal to 2x to the fourth power minus 3x squared. Again, first thing you have to do is to identify g of negative x. Solving this, our g of negative x is 2x fourth power minus 3x squared, which is equivalent to our given. So therefore, f of x is equal to f of negative x. Therefore, this graph is symmetric about the y-axis. The third, x squared minus 3x plus 6, solving the h of negative x, it would be x squared plus 3x plus 6. Since h of negative x is not equal to h of x, we will solve for negative h of x. So looking for negative h of x, it would be negative x squared plus 3x minus 6. Now we have here a situation that h of x is not equal to h of negative x, at the same time not equal to negative h of x. So therefore, we can say that if we graph this h of x, the graph would be neither symmetric about the origin nor the y-axis.